I will pass to the next speaker, Pilar Albaladejo Sánchez from ITENE. The presentation will be about chemical modification of cellulose, tailoring properties for advanced composite application. Pilar is a very good collaborator from ITENE, from Valencia. He's a chemical engineering by Alicante University and master degree in packaging, transport and logistic technologies. And she's working in ITENE in many European and national funding projects, mainly to develop and design new sustainable materials for packaging application and other. Thank you very much, Pilar, for being with us in this workshop.
Hello, thank you to you for taking me in account. Do you hear me well?
We can see you, Pilar.
And do you hear me?
We can hear you.
Okay, I'm going to share the presentation. Okay, do you see it?
Yes, we can see.
And now in full screen. Okay, so let's start. We are going to speak about the chemical modification of cellulose for tailoring different properties for composites application. My name is Pilar and I come from ITENE. First of all, a bit introduction. The technological center where I work is located in Valencia, in Paterna. And we work mainly in 4 areas: sustainability materials and technologies for the circular economy, the packaging safety, design and functionality, the chemical exposure and environmental monitoring, and the part of logistic and smart mobility. We work in all the value chain of the packaging material, starting from the raw material and finishing with the part of recycling and also the logistic. And in this value chain, we work with different actors in the packaging sector, in the materials synthesis and additives, in the formulation, also the interaction with the packaging and the product, the part of printing surfaces, also a biotechnological department to valorize wastes, the recycling technologies, among others. Well, we have several labs to make all this possible, as you can see here, the list. And we have also several accreditation, like for example, the one for compostability for the packaging materials, also to evaluate the migration, the safety of the packaging materials for the food sectors. And we are the first lab approved by Amazon to evaluate his packaging. And now that you know a bit about ITENE, starting with the cellulose derivative additives that we perform in REDONDO Project. First, the introduction, why we select this additive. As you know, we want to go from a linear economy to a circular economy where we reduce, reuse, and recycle the materials that we use. For that, we have different legislation and directives in Europe and also here in Spain that are focused in these objectives. The one that you see in the screen mainly aim that all the plastic packaging will be recyclable for the 2030. And we also want to reduce the packaging waste 50%. And it's important to remark that the compostable packaging are excluded of these numbers. So taking into account that we need the circular economy, the cellulose is one material that fits all the requirements with this circular economy. Is a renewable material, is recyclable, and also is biodegradable. And that's why we are working in these cellulose derivatives additives. In REDONDO, we developed 2 different types of additives to use in the composites application for the cables. One of them is the microfibrillated cellulose that we obtain with a mechanical treatment of the fibers that we cut it in small pieces. So we obtain a diameter smaller than 100 nanometers. and you can find in the literature as MVC. MVC, that is cellulose nanofibers, CNF, you can find it as with different nomenclature. And also we have developed cellulose nanocrystal by acid hydrolysis. You can also find it by CNW, cellulose nanowhisker, because when you evaluate it as the microscope, it's similar to the cat whiskers, so that's why they are calling like this. And to obtain this cellulose nanocrystal, we remove with the acid hydrolysis the amorphous part of the fibers, having only the crystal part of the cellulose. Well, why these additives? Because they are recyclable and biodegradable, as we have said. Because they have low density, so they improve the packaging and the material in general lightening. They have thermal stability and also excellent mechanical properties. And finally, this is more focused in the packaging sector. They improve the barrier properties of the materials. Well, these cellulose derivative additives, they have some challenges to go to the market. We need more industrial infrastructure. We are limited because they are not very known to all the sectors. We have now high production cost and energy intensity, and also different quality depending the raw material that you use and the process. So that's these projects, for example, helps us to improve this, reducing costs and also improving the quality of this type of materials. For the part of the microfibrillated cellulose, we select the disintegration technology. For that, we have this pulp, that cellulose pulp that you see here from different raw materials, and that is mainly cellulose and water, and we put it in a mill with two rotating stones. One is fixed and the other is rotating. You put the stones close each other with a distance of microns, and with that, with several paces, we reduce the size of the fibers, blade pressure, and we obtain the final gel that you see here. That is only 2% of cellulose, but due to the diameter and the size of the fiber, has this viscosity and this aspect. After we produce this MVC, we determine the quality of it by 4 parameters that allow us to have a evaluation from 0 to 100 to evaluate the quality of this MVC. We determine the nanosize fraction, the turbidity of this suspension, the Young modulus of nanopapers that we produce with this additive, and also by the optical microscope, we evaluate the microscopic length. We put the 4 parameters in the equation that you see in the screen, and we obtain the value, the quality index value. Here we have the example of the MVC that we produced at the REDONDO project, the 4 parameters, and we obtain a quality index higher than 60, that is comparable from commercial MVCs that we have available in the market nowadays. We have also evaluated the thermal stability by TGA, as you can see here, that is important for the composite production. And as you can see, the onset temperature is 285. So for the temperature processing of the composite is good, and we are not going to have problems of degradation. And also we have evaluated the morphology by microscope in order to evaluate the final aspect of the MVC that we obtain in REDONDO project. On the other hand, as we have explained before, we produce the cellulose nanocrystal by acid hydrolysis. Here I include you a picture of the nanocrystal obtained at REDONDO and also one that are commercial, and as you can see are similar, and also the turbidity of the suspension that give us an idea of the size of this nanocrystal is similar to the commercial one that are the one from the company Celluforce. After we have this additive produced, we start with the modification of the cellulose. The modification, the goal is to substitute the AOS group hydroxyl groups of the cellulose with other groups. And with this substitution, we increase the compatibility of the cellulose with the polymer matrices. And also we can improve thermal properties. We can give flame retardant properties to the cellulose, and also hydrophobic properties. For example, here I put you the example that is more visual. Here we have a paper that is only recycled paper, and we include different amounts of this modified MFC. And as you can see, with 7% more or less, we achieve a complete hydrophobic paper only with this amount of the modified cellulose nanofibers. And in the case of the cellulose nanocrystal in REDONDO project that we are focusing the part of the flame retardant properties, we evaluate the synergy flame retardant effect of include the cellulose nanocrystal inside the layers of nanoclays, because the nanoclays are a flame retardant additive itself, and if we achieve including this cellulose nanocrystal inside the layers, we improve more the part of the flame retardant of this type of additives. And well, starting with the cellulose composites. First of all, what is a composite? What is component? That is the process to obtain a composite. Is mainly to mix two types of materials, organic or inorganic. We can mix blends of polymer with polymer with additives. That is what we have done at the REDONDO project, and then polymer with mineral fillers, also with pigment, with colorants. And what is important to mix this? We need to have good dispersion of the additives in the polymer matrices. If not, the properties of the final material, they are not going to be good. We can have points of break in the materials, so it's important to mix well. And in the case of cellulose, it's also more important because it tends to agglomerate itself. So if you don't have very good dispersion, you are not going to achieve a final composite with good properties. For that, we use a rotating twin screw extruder with modular design. So we can make or design specific screws to disperse well the additives and also don't degrade it in the case that they are sensible to the temperature. Okay, and what are the application of this type of composites? We can apply it in the packaging materials sector to improve the barrier, also to improve the biodegradable and bio-based polymers and make it more comparable to the conventional polymers, and the construction sector, also to improve mechanical properties and reduce cost. Also in the part of isolation materials are very used in the automotive sector to reduce cost, also weight. That is very important in this sector, and the mechanical properties, and another sector like textile, electronics, biomedical, among others. And well, starting with the examples of composites performed here in REDONDO project. Here first, I have included you a picture that, as you can see, this is a PLA matrix, a biopolymer. Here is an example of bad dispersion that we achieved at the beginning, and here is an example with good dispersion that you cannot see this point that you have, and you can see an homogeneous color in the matrix. And also here, first we determine the mechanical properties of these composites. And as you can see, the PLA is very rigid, so we don't want to increase or just to increase more the Young modulus, and more or less is homogeneous. And we want to improve, if it's possible, a bit the elongation of this material. And with some of the formulation, with a 3%, for example, we improve these properties. Okay, then an example of barrier properties. Here also I have included you a picture of the effect or of the design of the screw of the extruder. Here we have the first design that is not specific for this type of additive, and as you can see, we have brown color because we have some thermal degradation, and also it's difficult to see, but we have some points, and with the different designs of the screw in the compounding process, we improve the degradation of the additive and also the the dispersion, and we obtain this final transparent packaging material. After achieve this final material that is good, we evaluate the barrier properties, and as you can see, with a 1% of the modifying VC. In this case, we evaluate a cellulose nanofiber that is not modified and the modified one. So you can see that with the non-modified, we don't have this compatibilization with the polymer and the matrix, and we don't obtain this improvement in the barrier properties. And when we modify it, we increase these barrier properties. And also I have included you at 3%, and as we have commented, the cellulose tends to agglomerate itself. So when you put so much amount of this type of additives, you can also find the opposite at what we are looking for, and we reduce or we don't improve the barrier properties of the final material. And now another example, the one that is mainly from REDONDO Project, that is flame retardant nanocomposite. We have different formulation here. In this case, it's important to take into account that for the cables formulation, we have a very high amount of commercial additives that improve the flame retardant properties of the polymer. So in this case, that what we want is to reduce this amount of commercial additive, but we cannot substitute completely the commercial additive with the cellulose. But here you have different examples. This is the one with only the commercial additives, and here are the ones with the commercial additive reduced and the cellulose nanofibers substituting these commercial additives. And as you can see, regarding the ion modulus, more or less, we have similar values, or we increase it a bit. And the other one, also, we have some formulation that we have the same properties as with the commercial additives. And after having this mechanical property evaluate, we also evaluate the ignition or the flame retardant properties of burning it, and taking into account the dripping, the starting burning, and the time of burning of standard proof. Here we have a different formulation, and as you can see here, when you see a bar, it's like you burn it and then it's a stop burn, and we have to start again. So this is good. So why is that? For example, the formulation with the cellulose nanocrystals and the nanoclay is one of the better that we have performed in REDONDO Project. That is the one that we are continuing with. So to take home message, what we have reviewed in this presentation. First of all, we have to speak about cellulose derivatives, additives that are biodegradable, recyclable, bio-based, and can improve the mechanical and barrier properties of the composite materials. We have speak about two different types of these cellulose derivative additives, the microfibrillated cellulose or cellulose nanofibers and the cellulose nanocrystals. We have speak about the modification of the hydroxyl groups of these cellulose in order to obtain new properties, that is like the hydrophobicity and also the compatibilization with the polymer matrices to improve the dispersion. And we have to speak about the compounding process, that is very important to have this dispersion of the additive in the matrices in order to get the final properties that we are looking for. We have spoke about the different sector where the composites produced with cellulose can be used as packaging material, construction sector, the automotive, the cables, and as we can evaluate in REDONDO Project. And finally, we have some different examples of improvement in mechanical properties in flame retardant and also in barrier properties obtained with this type of cellulose derivative additives. And that's all from my side. Thank you for your attention.
Thank you very much, Pilar, for your interesting results and your presentation.